pizza left over, drinks over there if you want to get some. Feel free to take pizza at home after. Otherwise, restrooms are up the stairs there. There's an elevator here if you need that, and you might hear like a hydraulic sound, so just kind of ignore that. So what's DevOps Des Moines? We're a DevOps-minded user group in central Iowa. Obviously, everyone's in Des Moines right now, so. But yeah, meetings can range from discussions about different languages, frameworks, deployment patterns, various different things. Like last month, we had a Bring Your Own Problem event. That was a lot of fun, very interactive, so thanks everyone who came to that. If you are not able to come in person, you can also catch us on youtube.com/@DevOpsDesMoines. And really the objectives of our meetup are to learn, teach, share, network. So feel free after the event if you want to stick around and chat with others. And we are looking for speakers right now. We've got the next few months figured out, but after that, it's wide open, I think. So if you have a 15-minute, 30-minute, 60-minute topic idea, reach out to one of the organizers. Doesn't have to necessarily be specific to DevOps, but generally that's what we end up presenting on. And if you want to reach out to us, the organizers, Craig Lean, I'm Jonathan Tessman, Matt Vincent, Min Win's in the back there, John Langling's also sitting in the back there, and you can reach out to us on meetup.com/DevOpsDesMoines. We have a Slack as well, or LinkedIn. But yeah, I'll hand it over to Maria, so thanks.
All right. Okay, cool, thank you. I am presenting, yes, good. So hi, I'm Maria Jackson. I'm gonna stand not in front of that. I'm a software engineer. I've been, how long have I been? I don't know, 5 to 10 years in IT. So at some point I switched over to software engineering in that. I'm from the area, and the kind of things I enjoy, I really, ultimately, this is about how much I love DevOps. I found DevOps, and it was so exciting to me because I love the idea of having a tool that I could reuse, I could solve real problems, and I could see the effects of them. And when I came in and started working in DevOps, the thing that really troubled me is I can't apply DevOps to everything and everything. There was so many problems that, hey, DevOps is code commit to code deploy. Maybe it's a little beyond that, but it doesn't work on every single problem. And I wanted to find out, but what about all these other problems that I have? And so I started asking people around day after day, hey, what about this problem? What about this problem? And eventually I asked a friend, a software engineering friend, I know that automation, like sometimes it's too hard to automate something or not worth it, but like, is there a reason, is there reasons why you wouldn't automate something? And they said, have I got a 1983 paper for you? And then for the next several months, I read a huge number of papers and I got really excited. And this is kind of a little bit of a taste of that. It's not all papers. It's a lot cooler than that, unless you're really into papers like me. And then I've got some papers for you. So basically, I'm talking about automation to adaptation. What can I add to DevOps? The things that I'm talking about are not in superseding DevOps. They're just things that you can add and fit really well in to DevOps. You can think about them at the same time, etc. And some of these things you're already going to be familiar with. Some of these things you're going to say, oh yes, I know that. And then I'm going to say, but wait, there's more. So, and this is basically it. This is the talk. So we got DevOps on here, things that are highly repeated, highly standardized, right? And so when you look at DevOps and you look at the history of it, you can look at the book Accelerate, right? It describes itself as lean software engineering. And really what that is highly repeatable processes that are kind of based on manufacturing. And in fact, a lot of them are just based on the way Toyota manufactured things in the Toyota production system. So like we use the term Kanban, right? Toyota in the 60s had physical Kanban boards, right? So a lot of about DevOps is about highly standard repeated processes. And then we kind of move along the way into kind of the SRE world where we say, okay, yes, operations, but operations at scale. Because DevOps is merging developers and operations, and this is the Google branded version of SRE, but like how do you continue on with operations when things get more complicated? And so, you know, things like chaos engineering came out and SLOs and just, yeah, it's not quite clear where they stop and end. Maybe they're all the same, I don't know. And then part of that is this resilience engineering, right? I like to do it like this because it's more fun. So the resilience engineering is kind of a more academic approach. And if you like academics like me, you'll like that. But if not, we're not really going into that much. But you also have kind of the learning from incidents. So a lot of you, who has been in a blameless postmortem, right? Who was ever explained what that meant? Okay, for the people online, the thousands of people watching, no one raised their hands. So we're going to talk about that today. And so basically, a lot of this is not repeated, not standardized, but like to me, it's all in the same kind of continuum. It all kind of connects because I like it all, is maybe the connection, but a lot of people who love this also love this. So most notably, the person who wrote the introduction to the DevOps handbook, John Alspaugh, is the person who wrote the most famous learning from incidents information. So there's a continuum here, right? And you have people who write things for DevOps and SRE, like Jez Humble, he's in both. You have a lot of things kind of crossing over here. And so I just kind of wanted to make that connection here and kind of holistically, now I'm going to sell it to you. This is going to be awesome. All right, so now that was the overview. Now we're going to go in. So what's DevOps good for, right? Things you can standardize. We talked about that. So you got your standardized, and then all we have to do is checkbox, right? It's not, so it's standard again. So this turns into standardized. And we've done it. But the problem is that doesn't quite work. So the first one is standards are hard. This is, I'm going to show several XKCD cartoons because I really like them. So, right, it's very difficult to come up. We have these 14 competing standards. Let's standardize it. Now we have 15. These are hard, and sometimes it's because we're special, and sometimes it's because we think we're special. But I know it's because I'm special, and I think it's because all of you are special, not because you think you're special, right? Okay. The next one is like sometimes it's just like not worth it. Another cartoon. You don't have the time to standardize this. It's just not worth it. It doesn't come up enough. And then finally, it ends up just being like really hard to standardize it. It's just easier to manually do it because the maintenance costs on standardizing are just too high. And these are all things like we talk about, we understand, I think. Does anyone say, like, I object? Does anyone say, these three cartoons, do they make sense to you? Okay. There was a roaring applause for everyone online, just to let you know. Okay, but it isn't just this. There's more. So part of it is we're in a very, very complex systems. Does anybody have a really simple software engineering system that they work on? Anyone? Okay, does anyone have a really complicated or complex software engineering system? Okay. Some people aren't sure. They have neither. I don't know what they have. Maybe they don't have any software engineering systems. And we can kind of like understand even simple systems. So I have in here, like you have the butterfly effect, right? This is a pendulum. We can show the video, but I don't know if it's worth the effort because because I knew it was recorded, I wanted to make sure it was in a public domain. So basically, so it's on Wikipedia, their source. So here you go, a presumably simple pendulum started at basically the same time, and within 30, 40 seconds, it's completely working differently. This is the same pendulum, right? And so they're just videotaping it at different times. And that's kind of how our systems work. This is a simple example, but our systems don't always act the same. Has anyone had a system that worked every day for a year and then just stopped working one day and you had a production incident? Right? Okay, we had at least one person say yes. Okay, couple people. Right? And I have that presumably simple pendulum swing, but this is just the first architecture diagram that came up when I Googled. Like this is some sort of AWS thing, right? And it's complicated, but I've built these. I've implemented these much more complicated systems, and this is one system that interacts with many SaaS providers, other things at your company, etc. Like it's far more than a single pendulum, a lot more moving pieces. And so what ends up happening is we have these weird things happening. It's not just about, oh, we automated it and standardized now. Yeah, we automated and standardized now, and we still have these emergent properties. Like a classic example is, do you know when Buzz Aldrin and Armstrong, Neil, that's his name, Neil, they landed on the moon in the LM, right? The lunar module. And when they landed, they had 11 alarms going off. But none of them were a problem, and they knew it ahead of time, because what had happened is they had two separate systems that, through however they were positioned, basically had this weird electrical feedback loop that hit off all these alarms. And they didn't have time to essentially reweave the computer code in order for that not to happen. And so these kind of emergent properties of two systems that they themselves were working perfectly, you have things that result, both of the components were working perfectly, and then the result is that it didn't work. Nancy Levinson, an MIT researcher, she believes that but through her studies, that 90% of software incidents, in the way she defines it, is that they come through the components actually working. It's the merging of the components together that ends up not working. And so the other thing, besides we have very, very complex systems, right, is we have the difference between work as done and work as imagined, right? So this is a concept that has existed from what I could research, and I'm sorry, I cannot reference who said this, but because I can't remember, I didn't write it down, but since the 1950s, right? And we have these different concepts of, like, this is how it actually happened, and this is how we say it happened in our brains, and disclose this is how we tell our bosses it happened, and this is how our company tells us to do it. And they're all, they kind of overlap a little bit. Does anyone, maybe yours is like completely on top of each other, but mine isn't. Mine's different. And I'm a rule follower. Anyone who's worked with me knows I love following rules, right? And this still speaks to me, because we can write down exactly how we think things work, but it just doesn't work like that. We have way too complex of systems for us to explain. So we both have these emergent properties. We also have these really complex systems, and we have a huge number of them because we're never going to be omnipotent. We can't be everywhere at once. We only make a small portion of our systems, and we don't have an infinity gauntlet to help us. Sorry about that. So what does this end up meaning for us? It means this is why we're on call. This is why the first people started filing in, and someone says, well, they make a joke about someone having a production incident and they're not going to be here, right? That's literally the one thing said to the group before we joined, is because that's our lives. So I want to talk about, kind of segueing into that, but what do we do with these problems? Like, this is a DevOps group, and I think there's connections, and a lot of this stuff is tendrils that eventually overlap and combine, and there's no clear definition. So I decided that it was good enough and it fit, and Jonathan said it was okay. And if Jonathan says it's okay, then I can do it. And so we have a couple different concepts here, and none of them are special or independent from each other. They're just a big old mix. But Google said one day, another person said another day, and I think the people at Ohio State said this. Yes, they're different, probably, but it's not important. Maybe it's important to them. I don't think it is. And it's kind of like, we'll go back to the standardized and not standardized. So let's start moving into that not standardized. That checkbox that no matter how many times I click it in the UI, it isn't check. It refuses to be checked. So what do I do there? Well, we know that we have things like SLAs, SLOs. We have agreements a lot of times with our vendors. Maybe we don't have them, but I think a lot of us are in the cloud, and let's say we have an S3 bucket, and I don't remember how many nines. Does anyone know how many nines of reliability an S3 bucket has these days? Yeah, 75 billion, who knows? But we have, and this is, I like this from Splunk. They really say, how many nines are we getting here? And you're looking at this, and you're like, oh, well, that's like 3 days down. That seems like a lot. But like, wow, 5 minutes in a year? I have to be, like, I want to be this reliable, and I have all these nines. And you're like, actually, that's really hard to get to. And you are built on systems and interacting with a bunch of systems that are also having trouble getting to this, right? And so we can't make a perfect 100% system. It doesn't exist. Now, you might think it does, but no one in the history of humanity has ever achieved it, so good luck. And a lot of this, so the question becomes, if you're coming here and you're saying, it's just not worth your money, even if it is possible, let's say it is possible. It's not worth the money for you guys, for your company to spend to make it that reliable in almost all cases. So you have to start managing and saying, well, how reliable do I want to be? Well, and then you have to say, well, do I even have a choice of figuring that out? And the answer is, like, to some extent, because of chaos, because of all of these other things that happen, like, you have some control and you can make it better, but you're kind of at the whims of chance at some point, because you're going to have what some people call black swan events, right? And you cannot prepare. You would run out of money if you prepared for every black swan event. And so that's kind of, thinking about through, like, I'm going to argue that none of us, practically speaking, even if it were possible, are going to be fully reliable. We're reliable in a very generic term, meeting customer needs at a 100% level. We may be meeting customer needs, but our software isn't going to say I'm 100% up, or at least over the long term. So that means we're going to have incidents. We have planned for things, and we have unplanned for things. So we talked about DevOps. We plan for those things. I know I'm going to have a release today, right? But I also have things that are unplanned, and those are often called incidents. So in this, what we can do is, over time, we can start planning for things. We can put things in, and we can become more robust. And for robustness, what I'm talking about is I start making strategies that I can roll back quickly, right, in DevOps. I can do a canary deploy. I can deploy to a safer environment first. I can do a lot of things to make it so when something bad happens, it doesn't affect me. I scale with demand, right? But on top of that robustness, you also have resilience. You have the idea that we're going to degrade slightly, right? Maybe not all the way, but let's degrade a little bit. Or maybe we totally and utterly fail, but we get back quickly, or we learn something from it. And so how I like to think of this is these two terms is robustness. If you play D&D or you're like into video games, is like your armor class. And your resilience is like your HP. It's like your hit points. And so you have, and that's not a perfect example, mind you, but that's kind of, you need both. No one builds, because you can only pay for so much of either. And so when you build, when I go and I just got my 5.5 book, and I just started with my new character in my D&D campaign. I'm really excited. But I built my character, and by the way, my DM doesn't allow me to use infinite points. So I can't have 500 HP and 30 armor class. They just don't let me. I have to have some sort of combination that makes sense. I put this slide in there again. Who knows why? So I want to talk about, like, what does that mean from a learning from incidents perspective? That's because this should say learning from incidents. So let's say we come back in here and we say, okay, we are going to fail sometime. We're going to have these incidents. We're going to get that call in the middle of the night, right? So how do we deal with that? One, we have like incident response. This would be great. And we have our incident commander. It's kind of, if you do, it's modeled off of how like firefighters work. But like, what do you do afterwards? What do you take from that? And the argument of like the learning from incident community is that this is a time that when we had that work as planned and work as imagined, we know there's a clash. We know it isn't working, and that's where we can learn something about it. I spoke really fast, so I'm going to take a second. Would somebody mind getting me like a sparkling water? I would love that. Thank you. Or just a water would be great, but I know there's sparkling waters. A lot of that is, but how do we do these learning from incidents well? And so a lot of us, we've heard these things like RCA, post-mortem. I'm going to drink this in front of y'all because I'm thirsty. All right. We have these blameless postmortems, but like, what does that mean? Well, it turns out, I thought for a long time that it was probably something that Brené Brown came up with. No, Brené, okay. It was something that warm and fuzzies, and it sounds great, and we can all be friends, and it's gonna be great. But it turns out a lot of it has to do with this. This is Nancy Levinson, who I believe I used her name correctly earlier, but I quoted earlier. But when learning how to engineer safer systems is the goal, rather than identifying who to punish and establishing liability, then the emphasis in accident analysis needs to shift from cause, in terms of events or errors, to understanding accidents in terms of reasons. And basically what Dr. Nancy Levinson is saying here is when we look at these incidents and we do these blameless postmortems that no one explained us how to do, I didn't learn how to do, so we're in blameless mode now. That the idea is we're not trying to, unlike, we're in a big insurance town, right? We're in the second largest insurance town in the world. Hartford, Connecticut is number one, but we try to ignore it. Like, it's important if you're running insurance to be able to point out, oh, who's at fault, so you can assign, and in a sense of making like an illegal sense. Absolutely, you need that. But in a software engineering sense, when we come back and we're figuring out what's going on, we don't really care who did it. It's not important. What's important is we figure out the reasons why. And the why that is because we gotta learn something from this. Because this is a point in time where our work as imagined and our work as done didn't make sense, or when the complexity of our system exceeded our knowledge or ability to understand prior. Because if we understood that it was gonna happen that way, and that it was likely to happen, and the likelihood to happen, we wouldn't have designed it that way because we're really smart. We made that trade-off, even if we knew that it could happen, because we didn't think it was likely. We didn't think it was going to happen, because we're not omnipotent here. We're not Thanos, who I don't think is omnipotent, but I like that picture. So, the other things how to do this practically, I really like the agile retrospective prime directive, which is regardless of what we discover, we understand and truly believe that everyone did the best job they could, giving what they knew at the time, their skills and abilities, the resources available, and the situation at hand. And the deal is, you don't have to think that that's real. I don't think that's real all the time. But it's really helpful to act like it is. Because when you do, I'm not omnipotent. I can't possibly know what that person was thinking at that time and why they did that. But if I am curious and I think, I wonder why they're doing it that way, then I can say, wait, I've learned something new. Because there's no reason getting together in a meeting and discussing something and debating something. And obviously, we live in the real world. We're pointing fingers. Sometimes what happens, yes. I'm acknowledged. But I'm living in fantasy land right now where we're learning. And so really what we want to do is this is the time that we have to get together to pick each other's brains, to understand why in the world did you do that? Well, because this, and this was happening in the circumstances. Oh, it turns out that was really smart. And that happens to me when I've been able to switch into that mode, which is not natural to me in any way, shape, or form. I have been shocked at what I have learned over the years and how often what things people do actually would have made sense to them at the time. Because I'm a mean jerk a lot of the time. Like, I'm not the warm and fuzzy person. I'm not. I don't want to believe you. I want to blame you. Absolutely. Because it's really fun to blame other people. But it turns out when you're curious, you learn some stuff along the way that helps you later. So it's kind of nice. So another person, Eric Hollingell, the purpose writes, the purpose of an investigation is to understand how things usually go right as the basis for explaining how things occasionally go wrong. The vast majority of the time that we're looking at our systems, we can take into account, it's like, whoa, it actually goes right a huge amount of time, and we can look and say, what went well? And if one, because it makes us feel better about ourselves, absolutely. But that's really the majority of the time of how it's working. And so when we understand how things normally work, typically work, we learn more about our systems. And part of this is like, what then, when you do these blameless postmortems, right? Which is a terrible phrase. What should you be looking at? Instead of looking at what went wrong and saying, oh, it was definitely this problem. That definitely this problem that everyone knows, that person, that we all think that this is the problem, whether or not it is the root cause or not, that has already probably been fixed. And because that team, that individual who we all think that this is the problem, they're probably understanding and already fixing it. What we care about is actually learning from our larger system, because the likelihood of that tiny little thing accidentally aligning and being perfect and then we stepped back 3 times happening again is really unlikely. What is likely is us learning about our larger system and seeing things that are these patterns. Not that it's stepped back 3 times and we could have to make this never happen again. It's probably not gonna happen again, right? I don't have a lot of incidents that happen 16 times. I have a lot of patterns that happen 16 times in my life, but it isn't about that. So it's about identifying things that are easy to solve because we have limited time and money. It's about preventing large classes of incidents, not necessarily this specific incident or this specific tiny thing that we happen to identify as the root cause, and whether or not it was the root cause or not because we're not particularly good at identifying it because we've never been trained to do so. We figure out how to fix things, not how to diagnose things perfectly. It's not important that we diagnose it. It's important that we fix it. And then over which we have the greatest control. So that's a paraphrase. All right, so how practically can you do this? What are the guides, etc.? So back in, I don't know, 2012 or something, Etsy actually put off what's the debriefing facilitation guide. So it's like a 16-page document. It kind of walks through how to do these in much more detail in a very organized way. So if you're interested in if you're sick of doing your postmortems the way that you're doing them, and you think that they're swear, we're on YouTube, that you can take a look at this. It's really easy. It's 16 pages, and I honestly, there's charts in it I just use for asking people questions, oh yeah, this thing totally needs to replace, and I say, huh, how do you know that? And then they're like, oh, it's because of this, and people love it. People really like when you ask the questions that way, and they get excited. So back. This is an opportunity that we can say, hey, these are all different, yay. When we align these a little bit better, we're gonna understand our systems better. And so that is the end of my talk, and I'm ready to answer any questions that you have, but I have to figure out how to stop sharing. Perfect, yay. Cool. Preceded question, go, Jonathan. Min's lucky he's in the back. Because he's the other person that I know their name. Yeah, yeah. That was a question. That was a really sneaky question to get out of question asking. Wow. That's a pro there. That's a pro. All right, I'll just start asking you all questions. All right, who has been in a blameless postmortem recently? Anyone? Who's ever been in a blameless postmortem? Okay. Let's see here. Was it good? Did you like have value out of it?
It was okay. It was quite a while back, like over 5 years ago.
Okay.
There may have been other postmortems. They weren't called blameless postmortems.
Yeah.
But I remember that like Sev 2 blameless retro situation, and I was pretty junior at the time, so it was actually nice to hear that blameless phrase, because it was like, okay, we're going to be like productive here. We're not just going to, explore the problem and blame someone. So that tone of the meeting, I think, was good. Yeah, and so we talked about what went wrong and why it happened. Yeah.
Do you think that you would? Did anything that I say resonate with your experience around that incident review?
I don't know if I would relate it to information that you presented necessarily, but I do like the Venn diagram a lot, because I think that's very true. Like how disparate it is, and how you're always kind of hiding some things over here or over there, and it's like, listen, the work's getting done, it's fine.
Yeah, like just the way you describe the word is discloses. This is what I'm telling my boss. Like, yeah. Exactly that.
And the intersection of all of those is like this big. I had to figure out where the intersection of all of them was.
And I believe this is Stephen Sharrock. I don't actually quite know the pronunciation on that. That is the original, the person who originally drew it. But the concept has been around, and I think it was like maybe made in a couple different places independently, but at least since the 50s in France. Cool.
All right. The thing I think that resonated with me when you're talking about blameless postmortems is we've done postmortems for like many years. We get, same people, but what we don't talk about like some of that intro stuff about blameless and getting to the reasons, and it's beneficial to like the new people on the team, especially junior developers who, are probably sensitive. They're just not used to it, and also doesn't understand the dynamics of people and stuff, and can take things the wrong way. So I think that's good to do, even if you've done them for a long time.
Yeah, like the way that I've always thought of the postmortem is, I think you kind of said this too, is don't look at the person, but like the thing that allowed the person to do what was bad or whatever.
How do you guide those conversations? How do you keep it from, because we have,
Yeah.
There's always somebody that wants to fight that day. So, how do you?
Well, I'm obviously an expert and really good at all those things, clearly, because I'm a software engineer and that's what we're best at.
That's what I'm asking.
But in reality, like a lot of the thing is to me is like looking at why the person wants to assign blame, right? Why is it important? And part of it is one, it's supernatural to assign blame. That's a humanity thing, right? It's great. We love it. But it often gets in the way of learning, because if you have a lot of blame, then the work is disclosed. Like this just furthers apart, right? And so it's always been interesting to me when you have like leadership who's like totally bought in, and then you have this one person who's like, wait, why are you so like, why do you need to find this? And just like, asking maybe like questions there's actually questions in the Etsy debriefing guide that talk about like follow-up questions. They're like, oh, but we need to blame somebody. And you're like, how do you know that? Because there might be like something where, hey, they know something, let's say, oh, then I will be blamed. I want to protect myself. And that's like really good information to know. Now, maybe that isn't something that is great for a large audience to discuss. Maybe that's a one-on-one, but it's good to know that.
Also, if we start casting, blame on stuff, karma has a way of kicking you in the ass the next time.
I've luckily never made a mistake, so it's all good.
No one is perfect. No one has a monopoly on perfect PRs, perfect, operating.
One of the things maybe to point out is it's not just, so one of the things that they find in studies is when people review things, what will happen is they say, well, it's human error. And you'll see it this week, right? There was a bunch of news stories about major incidents happening, human error at the end. And what they consistently find is, what people will do is they'll say, okay, here's the problem, here's the next problem, here's the next problem, here's the next problem. Oh, human error, it was human error. Okay, here's the problem, here's the next problem. Oh, it's human error. They just stop there. Every single time that it's human error, a lot of times it happens. At some point, there's going to be a time where work as prescribed is different than work as done, but that was already happening the entire time. And probably you solved a bunch of incidents by not doing that. You actually probably prevented a huge number of things, right? But when you come back and say, well, oh yeah, they didn't follow procedure, the problem is one, you limit the work is prescribed, work is done, figuring it out, how that's different. You limit that learning and that sharing and the experience. But you also get to the point where you're like, oh wait, we just should have changed the work as prescribed a long time ago, and normally that's actually like what's keeping us from having this other major problem. And so it would be, like I would love, because I really love rules, I would love all these things to be the same. And my entire life is like me pushing these to be the same because it would make me feel good. But even I have to accept that that isn't going to happen, which is horrible. But that's the thing is like you can't, the technical term is counterfactuals. You can't know what didn't happen. Like, oh, well, if you wouldn't have done that, how do you know that it wouldn't have happened? How do you know if I would have followed procedure that none of these bad things would happen? You don't. And how do you know that something worse didn't happen? You just don't, and you weren't there at the time. And so it doesn't mean, obviously we have laws, we have but in that we do have to establish those things because we have courts and everything like that. But in software incidents, generally, we're just trying to figure out how to make our system better. Like it's just not, the stakes aren't generally that high.
The other, I'm also like more of an optimist versus a pessimist, or look at the better things.
Yeah, what went well?
This week we have 3 PRs, all 3 of them failed in production in a row. But that's the bad side. But the good side, if those would not have happened, they didn't reveal like some testing gaps that are now fixed because we went through and found them, and things are better. We went through the continuous improvement.
That type of mindset of thinking about continuous improvement a lot of times comes down to the culture.
Yeah, absolutely.
The team, the company, for that matter. My experience is at a time when I was a junior developer, I would have been like, first indication, oh, I'll reach see, annotate, or get blamed, see who wrote this piece of code. And as I've gotten more experience, I've found that I don't really care, and I don't really. That's not super important to me. I'm more interested in what can I do to improve, move forward. The same thing happens when you get into a team and you think about it in terms of whether you're doing a retrospective.
Yep.
And focusing on that, and focusing on hey, how can we improve as a team. But I do think it comes down to culture, and there have been many teams I've worked on in the past where they're very much interested in who made the mistake. They're also under this impression that bugs aren't a bad thing and that you'll never have bugs, and that they're also under the impression of that applications exist that don't actually have bugs at all.
Yeah.
And that is a in my opinion, that's a bad way of thinking about things. So I have seen that it's a learning opportunity for experienced people.
Absolutely. One thing, kind of listening to this as like a kind of holistically, one thing that I might want to reiterate from this, I think I agree with what everyone has said here, but one thing that hasn't come up, and I want to reiterate, is the idea that like, we might not be super great at figuring out actually what went wrong. Like that, it's possible we figured out how we fixed it. And sometimes what we said, well, oh yeah, well this person, they had to do a PR because this messed up and this bad thing happened. But really, we didn't have one thing that went wrong. We had a bunch of contributing factors that affected, that eventually happened in one environment that delivered this result. So it's not about going and saying this is the root cause, this is what happened, this is the problem. It's actually about saying there's this whole amount of different things. It's like my example with Buzz and Neil, where they had two perfectly working components and they both had electrical fields and it caused 11 alarms when they're landing the lunar module. And guess what? They still landed it. One small step for man, one giant leap for mankind. Total success. But that's the thing, is many of these problems, and where we say this is the problem, there was many things that happened. Many things and many layers that happened. So you both had, we figured out these 8 contributing causes, and then what were the reasons behind those? And you can literally go infinitely. That wouldn't be worth your time or your money to do. But it's one way to, instead of with the concept of blameless, it's not just about making a healthy environment. It's literally understanding the limitations that we have as humans who pattern match and cannot, not only can we're not omnipotent, we can't see into the future, we can't see into the past perfectly either. We can't even see into the present perfectly, right? Like, I'm at the front of this room and I barely can see all of you right now. I don't know what the majority of your names are, and I probably met some of you like 3 or 4 times, so it's embarrassing. But like, I know these things, and I don't have, but you know, hey, I'm still able to come here. It's still working. And so, that's the thing, is that we just can't know everything that's going on either. There's going to be things that we never caught. Like, we didn't catch that bug in time. You also didn't catch all the contributing factors by the time that you got to the incident review. Just because you thought you didn't catch that bug, what about the other bugs that you didn't find? What about the other things that were causes of this incident that you didn't find? There's a huge amount of stuff that you don't know. And what you are seeing is a small microcosm of what happened, but you can still learn from it.
I'd like to say that there also might be like a case where like the bug existed the entire time. It's just you had the right you made the right environment for it to explode. That's basically it. It wasn't really anyone's fault. It always existed. It's like baking soda and vinegar. It doesn't start bubbling up until you pour it.
And there's nothing wrong with baking soda, and there's nothing wrong with vinegar, right? I find them useful. Okay, I don't really cook in my family, it's my spouse that does, but he finds it useful, and then I eat it, so then it counts. All right, I think, does anybody else have like any closing questions? Like, I'm dying to ask Maria these questions. Oh, that was great.
Right away. I don't know about that. So you mentioned SLAs, and you talked about like the various nines and so forth. So I've been a consumer of SLAs, primarily through cloud providers.
Yes.
But I've never set SLAs or been involved with being responsible for an SLA.
Yeah.
So like the stakeholders on the apps I've worked for usually either say one of 2 things, like it doesn't really matter, I don't care as far as like how reliable or how fast it needs to be, or they say it needs to be fast. And then it's like, okay, well, like how much do you not care, and how fast is fast?
Yeah.
And you have to kind of like suss that out, and usually the app runs and basically it's okay.
So what you've just described to me, as I understand it, is you have done a non-technical SLA, SLO. You've done the hard part. You just didn't put it in code. So you just made an agreement, you discussed with people, because a lot of these things, and so like their contracts, right? You didn't necessarily put it in place to make sure that contract was maintained, but maybe you had a good idea, and you didn't have something, but you had something that was an agreement, and all that an SLA, like SLAs, SLOs, SLIs, all that is just making it totally formal, putting it into code. There's a great book by Alex Hidalgo. That's the SLO, I forget what it's called, SLO book, but if you have a O'Reilly subscription, you'll be able to take it of it. It's 600 pages, so warning, but it's math. But if you're not convinced, Dr. Forzigan, who wrote the Accelerate book, who is one of the writers of the DevOps Handbook and was the lead researcher on Dora metrics, like that's what she's suggesting doing, is writing SLOs. Jez Humble, who also wasn't the lead, but was the other two things, that's what he does all day now, right? That he writes SLOs. That is what he's giving talks on. He has called Why is my Expo Slow, SLOW, that even has advanced uses of SLOs that nobody else needs to, I don't need to worry about, but it's a good talk. And so like what you're doing is really actually the hard part is that discussion. Cool, thanks.